Hello guys, welcome back to the university, and if you are new to our channel, please click the subscribe button and hit the notification bell to get updated whenever we post new videos or new lectures about physics, about mathematics, about chemistry, biology, and earth science, and probably about school subjects, about the subject matter that you encountered in school. It will ensure that you will have good grades from now until the future. Alright, so let's dive into it and explore the concept of free fall motion. I hope you are familiar with high structure like this, wherein some daredevils or stuntmen are trying to jump from the top of the building or top of this structure, and once they jump, they are under the influence of gravity, and hence they are in a state called as free fall motion. So once they jump, there are variation in their weights. The question is, which one will fall first? Lighter objects like this face mask, or heavier objects when dropped at the same height? I hope you are able to see the results. Alright, so does air resistance matter? If there are variations in the result, you will reason out because the face mask is lighter or the feather is lighter and there is strong wind and so on and so forth. So we are going to explain all of that here in the university. Alright, so and you will notice that there is a difference in their speed. Alright, so is it constant? If it is constant, what is the constant value? We are also gonna determine that. And since this is about physics, you will expect a little bit of mathematics. And we are going to determine the equation or formulate the equation that will describe the free fall motion accurately in a mathematical manner. Answers to these questions are determined experimentally. Alright, so one famous experiment was conducted on the moon during the Apollo 15 mission by the astronaut in the person of David Scott in the year 1971. He had performed the hammer and feather experiment on the moon. So if you are on the moon and if you're gonna drop a feather or a hammer and the hammer simultaneously, the question is which of the two will hit the surface of the moon first. So if you want to know the result of the experiment, I'm gonna leave the link below, which is this one, http://www.archive.org/details NIX 15 1998 blah blah. Alright, so you just have to visit that and you will know the result of the experiment. Alright, moving on. We define air resistance as the force of friction. So when we say friction, it tends to oppose or to slow down the fall of a certain body. So air resistance matter because it counteracts the force of the acceleration due to gravity. So there is a big factor. So air resistance is a big factor. On the surface of the earth, if we are going to drop a hammer and a feather on the same height, the hammer will fall first because it is not so much affected by air resistance. On the contrary, our feather will fall later or slower compared to the hammer because it is largely affected by air resistance. So air resistance is a big factor. So we tried to answer the next question, which is which object will fall first, lighter object or heavier object? This experiment was, or the answer to this question was determined by Galileo Galilei in 1564 to 1642 in the Leaning Tower of Pisa. Okay, so on the top of this particular Leaning Tower he conducted the cannonball dropping experiment, wherein he dropped several types of cannonballs: small cannonballs, or lighter cannonballs, and heavier cannonballs. Alright, so both of them are spherical in shape, so the effect of air resistance is minimized. So he has found out that there is just a little discrepancy on the results. He must have concluded that there is a particular constant value of acceleration due to gravity. And how can we determine the value of this constant acceleration? Alright, so during those days, we do not have the complicated clocks or watches to get the time. So what Galileo did is vary the experiment and create a certain time measuring tool of interval, and he used the fluid. Alright, so as a clock. And to control the ball, or the motion of the ball in one path, and to determine the length of the path, he used a certain inclined plane. So he tried to get the distance traveled by this particular ball along the ramp with respect to the flow of the fluid. So that is how ingenious he is, because we do not have accurate clocks during those times, or stopwatches during those times. He had devised another way on determining the rate of distance traveled by the ball to the rate of flow of the particular fluid. So Galileo played on his setup. Okay, so he tried to vary the height or the starting point of the ball, and measure the distance. Okay, so that is traveled with respect to his ingenious clock, which is the flow of water. And he has found out that after repeating such experiments, he always found that the spaces traversed by the ball is always equivalent to the square of the times, and yeah, it is all true for all the experiment. Meaning to say, it is proportional to the length of the time traveled, time squared, and a certain constant. And we are going to determine that particular constant in the next mathematical analysis. So if we are going to repeat the experiment today, having the complicated clock and timing apparatus or measuring apparatus, we can gather this data. Alright, we have the distance and we have the time traveled, and we can graph it. Alright, so we are going to pay attention to the table here. Distance 0 meter at time equals 0, then 5, 20, 45, 80, 125, and 180 respectively. And once we graph it, we show that the graph of this is a parabola, and it concludes that we are indeed dealing with a quadratic equation. Okay, so using the data and a little bit of mathematic tricks, okay, so we can see that this is the time covered, or that has passed by, and this is the distance covered, and the distance covered seems to follow a certain pattern, and in mathematics this is called a quadratic sequence. And a quadratic sequence has a first difference and second difference. Okay, so we're gonna get the first difference, that is 20 meters minus 5 meters, and that's gonna be 15. And we're gonna do it with 45 and 20. We're gonna do it with 80 and 45, and 125 and 80. So those are the first difference: 5 meters 15 meters per second, 20 meters per second, 35, and then 45. And then we're gonna get the second difference, that is 15 minus 5, 25 minus 15, which is 10, 35 minus 25, which is 10, and 45 minus 35, which is 10. Okay, you will see that the second difference is constant, and that is around 10 meters per second in this graph, or yeah, so in this analysis. But actually 10 meters per second is the value of acceleration due to gravity, or yeah, so only the unit is wrong. So here we have found out that there is a particular constant which is equivalent to, or nearly equivalent to, 10 meters per second. So we're gonna do a little bit of mathematical analysis again to formulate the exact equation using the quadratic equation. So according to Galileo Galilei, so he have found out that the distance traveled is proportional to a certain constant and to the square of the time. Okay, so that is equivalent to distance traveled times, or equal to, second difference, because we found out that that is the constant. Alright, so according to our data table, and using the quadratic sequence analysis, that is the constant, and that is multiplied to the time. So from this observation, we are going to formulate our equation. Okay, so we can write it as d, or distance traveled, for d is equal to k, which is the second difference, times k. K is a constant, I just call it a constant like that. And plugging the observation by Galileo, so it is equivalent to this one, t squared, or the square of the time. So the question is, what is the combination that will lead it to be equal to 5? So I can do it by introducing a constant called as 1/2, and then 10, and then t squared. So if we are going to substitute it for a value of 1, so that is 5 is equal to 1/2 of 10, which is 5, and then 1 squared, so that is 5 is equal to 5. So our formula is now equivalent to d is equal to 1/2 k squared. Alright, has a value of 10, or that is our value of acceleration due to gravity. So we can write it as d is equal to 1/2 gt squared. So that is how we formulate the equation for the free fall motion. So to wrap things up, okay, so the value of g is equivalent to the second difference, which is it has a constant value of negative 9.8 meter per second squared. So why negative? The negative sign there indicates that it is directed towards the center of the earth. And you can also use the formula pi squared. Alright, so if you square the value of pi, it will have the value of 9.8. 9.8. Alright, so square pi and you will get your formula. Okay, so generalization, air resistance plays an important role in Earth. Alright, so but in places wherein there is no air resistance, doesn't matter. Okay, so weight of the object does not matter. Okay, because it's not included in the formula. So whether heavier or how heavy the object is or lighter the object is, it will fall. It will reach the bottom of the ground at the same time. Alright, just like doing that. And yeah, so in the absence of air resistance, lighter object and heavier object will fall simultaneously. Alright, so I hope you guys were able to understand this lesson. Okay, before we move on to the complex part, which is heavily problem solving, about problem solving. I hope you guys were able to understand the basic concepts of freefall motion. We are done with the introduction of the concept, and all that is left for us to do is to apply the concepts, apply the formula in solving real world problems. Alright, so here is the problem solving that we are going to deal with. So, because as I'm always telling you guys, practice makes you better. Alright, so the scenario is like this. You are on top of the building and you are playing with your ball. Alright, so you try to throw the ball vertically upward. Okay, so it leaves your hand with an initial velocity of 15 meters per second. Alright, so after quite some time, this ball will actually reach its maximum height, and there it will have its velocity or final velocity momentarily be equal to 0. Alright, so at that point in time, the earth will actually apply or is always exerting its gravitational pull to any object, so the ball will start falling downward. Alright, so on its way back home, down to your hand, you miss to catch it. So the ball is continuously falling towards the ground. Alright, so that's the scenario. So based on this scenario, you are asked, or we are asked, to find the maximum height reached by the ball. And we are also asked to find how much time it takes for the ball to reach the maximum height. Then, in part B, you are asked to look for the acceleration of the ball when the ball is in its maximum height. So we are going to determine if this is positive, negative, zero, or undefined, or whatsoever it is. Okay, so and then in part C, we are going to look for the position of the ball, position and velocity of the ball after 1 second or after 4 seconds after it leaves our hand. And then lastly, in part D, we are going to look for the velocity of the ball when the ball is 5 meters above the railing. Alright, so you will notice later on that there is no easy solution for this, and we have to challenge ourselves to look for a new formula that we can use to solve this. So let's start by listing our formula, okay, which we have just derived based on the study, or in our previous study of rectilinear motion. Alright, so in rectilinear motion, AX is the acceleration in the x-axis. Alright, but right now we are dealing with vertical acceleration, which is given by the Earth. So we are using G in place of AX. So this formula, AX is equivalent to BF minus BI all over T, can be written as G, because that is the value of our acceleration. Alright, and it is constant, is equivalent to BYF, or the final velocity in the y direction, minus BYI, which is the initial velocity in the y direction, all over the time. Alright, so you will see that we can modify the equation for the displacement that we just have used in the study of rectilinear motion. So if you missed that video, the link is in the description below. You can visit that, and then so that you can check. It will serve as your review. Alright, so right now we can use D is equivalent to BYI times time plus 1/2. Alright, so times negative G. Alright, so because this is constant, negative, that means it is directed downward, and it has a value of 9.8 meter per second squared. Alright, times the time. Alright, squared. And then, when we simplify this, positive times negative is negative. So we're going to write displacement is equivalent to BYI times time minus 1/2 GT squared. Alright, so, and it will be helpful if we can actually understand or totally understand the problem before we solve it. So the word threefold there is or means that the object is in has a constant acceleration, and that acceleration is the acceleration due to gravity. So all throughout, the value of the acceleration is not changing, and that is negative 9.8 meter per second squared. Alright, so our setup is so for easier understanding, so we can draw the particular problem. So when we collect our data and set up, alright, so we have to set up this data so that will the sign convention will be correct, because if we miss a sign, like for example we change the positive to negative, negative to positive, you'll be wrong. Alright, so that means it's easier for us to deal with it when we set it up properly. Alright, so here is our building, and the top of the building will be our starting point or reference point. Alright, so that will be the 0 position. Alright, so then the ball will leave your hand with an initial velocity of 15 meters per second, and then that arrow, the blue arrow, will be the imaginary path of the ball. Alright, so at the maximum height, you are asked to look for the value of the maximum height, and then the amount of time needed by the ball to reach that one, and then the acceleration when the ball is in its maximum height. Alright, and then you are also asked to find the position and velocity of the ball after 1 second, and then the position of the ball after 4 seconds. And then finally, alright, you are asked to look for the velocity of the ball when the ball is 5 meters above the radius. Alright, so we'll start by listing the formula and solving for the time for the ball to reach the maximum height. Alright, so we list it right here. So we know that the acceleration due to gravity is equivalent to Fy minus Diy all over time. Alright, and then there are other possible equations that we can use, but we will choose this one. Alright, because in this equation you will see that time is readily solvable. Alright, so we solve for the time by cross multiplying time to the both sides. Alright, and then you will get gt minus is equal to byf, so that is the final velocity in the y direction, minus dyi. Alright, and then divide both sides by g. Alright, so the time to get up is equivalent to byf minus dii over g. So this is the point in time wherein the velocity of the ball is equivalent to 0 meters per second. Alright, so we can actually add this formula to our list of formula right here. So you will see that as we go along the way, the formula are keep on increasing in number. So it's better if you will actually list them all, have a list, so that you will not be able to miss and forget them. Alright, so we can substitute the value, and we can actually find the maximum height or the time for the ball to reach its maximum height. So the formula that we are going to use is this one. T up is equivalent to byf minus dyi all over g, and we are given, okay, so this is byi, or the initial velocity of the ball when it leaves our hand, that is 15 meters per second, and then the final velocity of the ball when it is on its maximum height, that will be 0 meters per second, and then the acceleration due to gravity is negative 9.8 meters per second, and we are going to solve for this. Alright, so we substitute. That's gonna be 0 meters per second for BF, or for BYF, minus 15 meters per second for VYI all over 9.8 or negative 9.8 meters per second squared. And then you will see that we will get negative 15 meters per second all over negative 9.8 meter per second squared, dividing one another by another one. Alright, so the answer will be time to get up is equivalent to 1.53 seconds. Alright, so we can actually solve for the displacement or the height of the ball or its maximum height because we have the value of the time. So we can choose from this set of equation this one. So y sub 2 is equivalent to y sub 1 plus VYI times time minus 1/2 GT squared. Alright, so we find the maximum height traveled by the ball. So here is our given. Alright, and then here is our solution. So you will see that here we have add up 1.53 seconds as one of the value which is available to us right now. Alright, so the solution is the up is equivalent to VYI times time minus 1/2 GT squared. And then we're going to substitute that. That's gonna be 15 meters per second or times 1.53. Alright, minus 1/2 times 9.8 meter per second squared times 1.53 squared. That's gonna be 22.95 meters minus 11.47 meters. So that's gonna be the maximum height is 11.48 meters. Alright, so what we have found out as of the moment is the maximum height. Found out the maximum height reached by the object or reached by the ball, which is 11.48 meters, and the time it needs to reach that point is 1.53 seconds. So next is we have to find the acceleration of the ball when the ball is in its maximum height. Alright, so you will see that we can use this formula. BYF or the final velocity is equivalent to VYI minus GT. So we write it right here, and we all know that the velocity of the ball when the ball is in its maximum height is 0 meters per second. So VYF will be 0 is equivalent to 15 meters per second minus G times 1.53 seconds. Alright, so we are going to transpose 15 to the other side, so that's gonna be negative 15 meters per second is equivalent to negative G times 1.53 seconds. Alright, so we are going to divide both sides by 1.53, so that's gonna be negative 15 meters per second all over 1.53 seconds. So the answer will be negative 9.8 meters per second squared. Alright, so it's equivalent to negative G. And then dividing both sides by negative, so the answer is 9.8 meter per second squared is equivalent to G. Alright, so the acceleration of the ball at this point is in time is positive because of the direction of the ball. Alright, so here the ball is what we are talking about. It's not the earth, or it's not the acceleration of the earth, it's the acceleration of the ball. Alright, and at this point in time it matches the acceleration of the exerted by the earth. So that's gonna be negative 9.8 matches our acceleration of the ball, which is positive, so it cancels out, so it stops moving upward, right, and then it goes down, it starts falling back to the earth. Alright, that's why the value is positive. It's because of the direction. Okay, and that is the explanation there. Alright, so you might be looking for the answer on the web. The answer is here. So if you didn't catch that one, you can actually go back and watch the video again. Alright, so the next thing that we should do is to find the position and velocity of the ball after 1 second, after 4 seconds. So at those two time periods. Alright, so we have our given here. So Vyi is still 15 meters per second. The acceleration due to gravity is still negative 9.8 meters per second squared. And then the time is 1 second. So we are going to look for the position. Since we are looking for the position, here are the formula, and we can choose y sub 2 minus y sub 1 plus Vyi times time minus 1 half dt squared as our formula. So here, we know that the initial velocity is 15 meters per second. Alright, so we can actually substitute the values here. So we have 0 meters, which is the y sub 1, alright, plus 15 meters per second times 1 second, minus 1 half times 9.8 meter per second squared times 1 second squared. That's gonna be 15 meters minus 4.9 meters. So y sub 2 is equivalent to 10.1 meters. So after 1 second, alright, so the ball is 10.1 meters above the railing. Alright, so now is the time to look for the velocity of the ball when the ball is 10.1 meters above the railing, and that is on the time when the ball is have left our hand after 1 second. So we can work on with the formula down below, which is Vyf is equivalent to Vyi minus Gt. So we're gonna take this one and put it right here, and then substitute. Vyf is equivalent to 15 meters per second minus 9.8 meters per second times the value of time, which is 1 second. So plugging this in will give us, and solving will give us, positive 5.2 meters per second. Alright, so here is what we have found out. Alright, so and then we are also asked to find for the position and velocity of the ball after 4 seconds. So we use the same method that we just have applied. We have y sub 2 is equal to y sub 1 plus Vyi times time minus 1 half gt squared, which is the starting formula that we can work on. So we are going to substitute the value of Vyi, which is 15 meters per second, times the value of time, which is 4 seconds. Alright, and then here we have 1 half 9.8 meter per second times 4 squared. Alright, 4 seconds squared. Alright, so you have y sub 2 is equivalent to 60 meters minus 78.4 meters. And you will get negative 18.4 meters. So is there anything like 18.4 meters that we measure as a measure of distance? No, there's none. So the negative sign there indicates that it is moving away from you. Alright, so because the initial position is upward, and the positive axis is regarded as upward, alright, and the negative axis is that downward. Alright, so you will have 18.1 meters away from you, and that's downward. So you are going to affix the sign negative. Alright, so that's the importance of making use or setting up the axis in the right direction, because if you have set the axis on the wrong direction, you will get wrong answers. Alright, so next is to find the velocity of the ball after 4 seconds. So we can actually use the formula that is well used. So that is Vyf down below is equivalent to Vyi minus Gt. Alright, so we get that and substitute the value. We have Vyf is equivalent to 15 meters per second plus negative, so that is minus negative 9.8 meters per second squared times the value of time, which is 4 seconds. Alright, that's gonna be 15 minus 39.2 meters per second, and that's gonna be negative 24.2 meters. So the negative sign there indicates that it is directed downward and it's moving away from the reference point. Alright, so that's negative. Alright, so here is what we have found out. Okay. So here is the building, and the top of the building will serve as the reference point, and you are asked to find the maximum height reached by the ball, and you were able to find it, and that's 11.48 meters away from the railing. And then the ball consumes 1.53 seconds to reach the maximum height, and at the maximum height, the velocity and the acceleration of the ball is 9.8 meters per second squared. Alright, so after 1 second, you are asked to find the position of the ball, and you were able to find it, and that's 10.1 meters away from the railing, and the velocity is still positive, and that's gonna be 5.2 meters. And on its way back home, you missed to catch the ball, so that it travels freely and directed towards the ground, or towards the center of the earth. And then after 4 seconds, it has traveled negative 18.4 meters with respect to your position, which is the top of the building. Alright, and then the velocity is negative 24.2 meters per second, and that's directed away from you, which is directed towards the earth. So the next thing that we are asked to find is the velocity of the ball after it leaves your hand, when it is 5 meters above the railing. So here is our given. So 15 meters per second is our initial velocity, and then the position in which, or at which, we are asked to find the velocity of the ball, and that's 5 meters. And then the acceleration due to gravity is negative 9.8 meters per second squared. And check out the formula. So if you check out the formula, you will see that there is no equation that you can use to solve the velocity given displacement or position in the initial velocity and this one. So we have to derive another formula. So since it has something to do with the position, we can choose this one as our starting point, which is the formula y sub 2 is equivalent to y sub 1 plus vyi times time plus gt squared all over 2. So the sign convention, we just leave it as that, and we get that equation. If we get that equation, we can put it right here, and then isolate y, or this the element of position to the other side. So it's gonna be y sub 2 minus y sub 1 is equivalent to viy or vyi times time plus gt squared all over 2. Alright, so if you are going to check, we have the values for y sub 2, we have a value for y sub 1, which is 0 meters, and we also have the value for viy, which is 15 meters per second. We also have the value for g, which is negative 9.8 meters per second squared. And the only missing is the value for time. So we are going to look for terms, alright, that we can substitute for time. So that means we have to find some variables, some relationship that can replace t here, because we do not want t in the equation. It must be eliminated. Alright, so in the process, we have found out earlier that we can use bfy minus biy or vyi in over g in place 4 to substitute for time. Alright, so once we do that, this equation will change dramatically. Alright, so you will see that this is y sub 2 minus y sub 1 is equivalent to vyi times the quantity of vfy minus vyi or vyi all over g, because this term is equivalent to the time, you will see as we have mentioned, and then plus g all over 2 times this quantity, alright, which is Vfy or Vyf minus Vyi all over G, and then we'll raise that to the power of 2. Alright, so we are going to simplify this one. Alright, so by cancelling the innermost possible terms, alright, or similar terms in the innermost part of the equation, and you will see that's going to be G here and G here. Alright, so G over G is 1, and then you will see that on the denominator we have G here and we have 2 here, so we can cross multiply both sides by 2G, alright, and then we can distribute 2G, alright, so we will have 2GY times the quantity of y sub 2 minus y sub 1 is equivalent to 2 Vyi times Vyf minus Vyi quantity, and then plus this one. This term is a perfect square trinomial if you are going to expand this one, so raise that to the power of 2. Alright, so right now we have 2G times y sub 2 minus y sub 1 is equivalent to 2 Vyi times Vyf minus 2 Vyi squared plus Vyf squared minus 2 Vyi times Yf plus positive Vyi squared. Alright, so here you will see that there are similar terms. Alright, we mean to say that they have a common power, they have common variable, but they have unlike sign or unlike sign. So we have to deal with them, then cancel them up whenever possible, and we will see that the resulting equation will be 2G times y sub 2 minus y sub 1 is equivalent to Vyf, or the final velocity in the y-axis, squared minus Vyi squared. Alright, so we have the formula for Bf finally. Alright, so we have to take the square root of the sign, the terms. So take the square root of the left side, take the square root of the right side. We're gonna get Vyf is equivalent to the square root of quantity Vyi squared plus 2G times the quantity of y sub 2 minus y sub 1, and this is the formula that we can use. Alright, so we can plug in the values next. Plug in the values and solve for the final velocity. So when the ball is 5 meters above the railing. Alright, so our given, it's Vyi is equivalent to 15 meters per second, and then 5 meters will be our y sub 2, and then the acceleration due to gravity is negative 9.8 meters per second. So we have to substitute that. So Bf or Vyf is equivalent to the square root of 15 meters per second raised to the power of 2 plus 2 times negative 9.8 meters per second squared times the quantity of 5 meters minus 0 meters. Alright, so 15 squared is 225 meters squared second squared minus 98, alright, meters squared second squared. So you will see that they have similar units, and you can subtract that from the others. So when you subtract them and take the square root, you will get Vyf, or the final velocity in the y direction when the ball is 5 meters above the railing is equivalent to positive 11.27 meters per second. Alright, so we were able to solve everything completely. Alright, so here is what we have found out. We go back to the diagram. Here is our building, and you are on top of the building and you have your red ball. Alright, you throw the ball with an initial velocity of 15 meters per second. After quite some time, it reaches its maximum height, and the maximum height reached by the object is 11.48 meters. Alright, and then the time it takes for the ball to get up is 1.53 seconds. You are also asked to look for the acceleration of the ball when the ball is in its maximum height, and you were able to find it, and that's gonna be 9.8 meters per second squared. So why it's positive up to that point in time? Because that's the only time when the acceleration of the ball is equal, directly equal, but opposite in sign of the acceleration due to gravity. So it cancels out. So both accelerations cancel out. So there is no acceleration at that point in time, and it will fall down. So the acceleration of the ball cancels out the acceleration of the Earth. All right. So there are two accelerations. All right. So that means to say that the acceleration of the ball is positive and the acceleration of the due to gravity is negative, and they cancel out. So the trick there is there are two different accelerations here, and we are only referring to the acceleration of the ball. All right, because the acceleration due to gravity is always constant, it's never changing, that's always negative. All right, guys, so I hope you were able to solve that debate. All right, so and then you're also asked to find the velocity and position of the ball after 1 second, and you were able to find it, and that's good for you. And you were able to find that the ball is 10.1 meters above the railing, and its velocity is 5.2 meters per second. And then you missed to catch the ball. All right, so after quite some time, after 4 seconds, the ball is still on its downward flight. All right, so and that's you were able to see or find that it is 18 meters away from you. All right, and then the velocity is directed downward, and it has a value of negative 24.2 meters per second. All right, so that concludes our topic. All right, and then you were able to find or look for the velocity of the ball for the challenge problem. Right, so I almost forgot the challenge problem because it's really difficult. Alright, so you are asked to find the velocity of the ball when the ball is 5 meters above the railing, and you were able to find it, and that's very good for you guys. So that's you were able to calculate that its velocity is 11.27 meters per second. Alright, so that concludes our problem solving in free fall motion. Alright, if you have any questions, if you have any comments, or if you have any suggestion, violent reaction, comment down below, and I'm gonna read that, and then that will serve as positive criticism so that we can improve our video. And if you like this video, give us a thumbs up, please share, and then please click the subscribe button and hit the notification bell. So the subscribe button is just down below, and the notification bell is right here, so that you will be updated whenever we post new videos, new lectures about physics, about mathematics, about computer programming, and probably about the subject matter you encountered in school. It will ensure that you will have good grades up to this point and until you graduate. Alright, so be sure to get updated, notified. Alright, see you guys in our next videos. Bye bye.